Chapter 6.2, matrix inverses. Inverses are important, but this is a section where we're going to kind of use our calculator a little bit more. There's something about matrices we never covered, and I kind of skipped because frankly I didn't want to do it. However, you're probably going to end up doing it in college, and that's called row operations. And I feel like they're just the time they take to learn is something we're going to go through. So we're going to use our calculator for a lot of this. And you can actually, I'll show you how you can use the calculator on even section 6.1 stuff. Although when we take our quiz, you won't be able to use your calculator on 6.1 stuff. You can only use it on this kind of thing. So matrix I, it looks like it says matrix 1, but that's because it's bad font. Matrix I, basically, this is called the identity matrix. And what it is, it's basically the matrix equivalent to the number 1. An I matrix, let's just say, if I had a 2x2 matrix, the I matrix is this. If it was a 3x3 matrix, the I matrix would be this. And a 4x4 matrix, and maybe you'll start sort of seeing the pattern. These are all identity matrices. An identity matrix is just zeros and ones, and it's 0 everywhere except for the diagonal. The diagonal is all straight ones. This is the identity matrix. This is essentially the equivalent to the number 1 as a matrix. So that's essentially what it is. It can be any dimension it wants. It can be even a 1x1 matrix. A 1x1 matrix would just be the number. Why is it erasing when I draw it? Anyway, it's just the number 1. That would be an identity matrix as well. But yeah, this pattern continues. Every single element in this matrix is 0 except for the diagonal. The diagonal is all perfect 1. So that is your identity matrix. That's your matrix I. We're going to talk a lot about that and its importance later on. So inverse of a matrix, an n by n matrix A is said to be invertible if there is an n by n matrix B such that B times A and A times B, notice how they are the same both ways around. We talked about that in section 6.1, that's not always the case. B times A and A times B equals I, the identity matrix. Matrix B with this property is said to be the inverse of A, denoted A to -1 power. This is called A inverse. So when you see A to -1 power, I'm going to be calling it A inverse from now on. So when I see that, I'll be saying A inverse or inverse of A. So think of it like this, back to normal numbers. If I had the number 5, right? The inverse of the number 5, if you want to think of it, is the number 1/5. Because if you take the 1/5 and you times it to 5, what do you get? You get left 1. Which is why we say, you know, if I had 5x, or I'm sorry, well, yeah, let's say 5x equal to, I don't know, let's say 10 or whatever. It doesn't really matter. Right? What you're doing when you divide by 5, you know how we divide by 5 to get them to cancel out? You're not really, well, you kind of are dividing by 5, but what you're really doing is you're multiplying it by the inverse of 5. 1 times 5, or I'm sorry, 1/5 times 5. 1/5 is the inverse of 5, making it disappear, making it simply 1x equal to whatever you end up with over here, which in this case would be 2. So you're dividing by 5, but you're technically multiplying it by its inverse, the opposite version of 5. And that's essentially what this is all about as well. If we have a matrix, right, I want to know what matrix do I multiply it by that ends up equaling I, which is, you know, that matrix that we talked about where it had all zeros and ones throughout the diagonal. Again, this is the equivalent of 1 as a matrix. So matrix inverse, it's all about trying to figure out the opposite matrix, basically, to the one that we have that would, in a sense, give us, equal to 1. Also, a matrix must be a square to be invertible. We can't have, 3 by 2 matrices or 1 by 3 matrices. They have to be squares. So 2 by 2s, 3 by 3s, 4 by 4s, things like that. But not all square matrices are invertible. Some are, some aren't, just the way it is. Like I said, we're going to use a calculator for this. So here's your steps. There's 3 very important steps, all 3 equally as important. Step 1, input the original matrix into your calculator. Step 2, select the matrix and use the inverse function. That's a simple button on a calculator. And step 3, most important step, there is no step 3. Okay, it's only a 2-step process. Example 1, find the inverse of this matrix A here, which is 2, 1, 5, 3. So we're going to use our calculator. But again, the question I'm asking is this matrix here, 2, 1, 5, 3. What matrix am I multiplying it by to the point where it would equal I, the identity matrix? The identity matrix, remember, is 1, 0, 0, 1. In this case, because this is a 2 by 2, I know that all the other matrices in this problem I'm referring to are also 2 by 2. I know its inverse has to be 2 by 2. So that's the question, is I have this matrix here, but what matrix do I need to multiply it by that would end up equaling this matrix, which is, again, what we call I, the identity matrix. And we're just going to simply use the calculator for that. So if we go to our calculator, let me try to remember this, 2, 1, 5, 3. Okay. I'm going to discard that for now. Go to our calculator, and we'll put this matrix in. So here's how you do matrices on the calculator. So see, it says matrix, 4th button down. If I hit second, and then this x to negative 1 power button here, you can see I highlighted it red. It says matrix right above it. So if you hit second and that button, you go to your matrix menu. So there are 3 columns here: the names column, the math column, and the edit column. The most important one that we're going to have to deal with is the edit column. So as you can see, I've already made some matrices, but I'm going to go ahead and erase. Because go back to that. I guess I won't erase them. I guess I'll just edit them. So I'm going to edit this matrix A here. And I'm going to turn it into a 2 by 2 matrix, since that's the problem that we're talking about. Our 2 by 2 matrix, I already forgot what it was, is a 2, 1, 5, 3. Okay, so 2, 1, 5, 3. So I'm going to just type those numbers into my matrix. 2, 1, 5, 3. All right, so my matrix is now in my calculator. I'm going to go back to my matrix menu. So second matrix. I'm going to choose that matrix I just made. Remember, I put it as matrix A. So I'm going to choose matrix A. And, well, okay, hold on. I got to clear this out. I got to start fresh. Go away, go away, go away. Okay, quit. Okay, my calculator froze. Okay, now it's catching up. Can I go back? Okay, here we go again. Second matrix. All right, we're going to select matrix A, the matrix that I just inputted my 2 by 2 matrix in. And all we're going to do is hit the inverse button, which is the same as that matrix button before, that negative 1 power. That says A inverse. So this will tell me what the inverse of that matrix I just put in the calculator was. And there you go. It's 3, negative 1, negative 5, and 2. So 3, negative 1, negative 5, and 2. Let's put that in here. So 3, negative 1, negative 5, and 2. That is our inverse matrix. So what that means is if I take the 2, 1, 5, 3 matrix I just had, and I multiplied it with this matrix, which is my inverse matrix, I should get my identity matrix of 1, 0, 0, 1. And I kind of want to test that out. I just want to see if that's true or not. So let's take our calculator and let's experiment just real quick to see if that's the case. So I already have this matrix in my calculator. Let's go ahead and put this one in as matrix B. We'll see, we get 3, negative 1, negative 5, 2. Let's see if I can remember that. Go to my calculator. I'm going to clear that off so I don't have any issues. Go back to my matrix menu. I'm going to go to edit. And I am going to input that inverse matrix that I just got. So I think, hold on, I got to go back. I should really write these down, you would think. Actually, is it in the book here? Yes, it is. Okay, cool. All right. I'm going to go back to my edit screen. I'm going to put this matrix inverse that I just got as an answer. This is just me checking my work, by the way. Notice it's already 2 by 2. So 3, is it? Oh, crap. I broke it again. Maybe we won't. Well, you could do it in your own calculator, and it should work just peachy. But it's not going to work in mine because it's frozen. So I don't know why it keeps doing that. But anyway, take my word for it. Those two times each other equal that identity matrix. Anyway, back to this. Example 2. Find the inverse of this matrix. Again, all I would do is use it in the calculator. Go to your calculator, hit second, and then that x -1 button. And make sure you edit and make it a 3 by 3 matrix. Input all those values. Do exactly what we just did in example 1. You'll get the inverse. I'm going to try again, but I doubt it's going to work. Yeah, hold on. Can I control alt delete this? I don't know if this is still recording the screen or not, but we're going to find out later. Great, wonderful. I think when you use this app for more than like an hour, it gets really bad. It just stops working. And that's fine. All right. Let's input this 3 by 3 matrix in. Oh, look, it didn't even save my old one. How fantastic is that? I'm not even gonna bother checking my work that I was gonna do a second ago. All right, let's input my 3 by 3 matrix. What is my 3 by 3 matrix? 2, 0, 1. Okay, so here we go. 2, 0, 1. I have it in the book here. So 2, 1, -1, and 3, 1, -1. Oh, what the heck, man. I just think sometimes, Did I hit enter? Is that what's going on? 2, 1. This one's the -1. -1. What? Why? I apologize for this video being unnecessarily longer than it had to. I could edit this out, but the way the edit, I gotta just concentrate on what I'm doing here. I could edit this part out, but the way the editing program works, yeah, I knew that was gonna happen. In my program, it lets me cut clips off the end in the beginning, but not parts in the middle. It doesn't let me trim those out for whatever reason. Maybe if I buy the fancier version of it, it does, but it doesn't otherwise let me do that. So you're kind of stuck with this struggle bus in the meantime. All right, I'm gonna go down here. I'm just gonna strictly use my mouse keypad. All right, -1. All right, yeah. Enter, that should be fine. All right, 3, 1, -1. Hallelujah. I'm going to check to make sure that that's right. Yeah, that's the same thing. All right, so now we're going to quit this. The matrix is inputted. It's all saved. I'm going to go to my matrix option. I'm going to choose my matrix A, my 3 by 3 matrix that I just made, and then I'm going to do the inverse of that. And voila, there's your inverse. Yada-dee, yada-da. It's pretty simple, pretty straightforward stuff. Let me see if there's anything else. Oh, there are some other things I want to talk about in this chapter. So example 3, same thing. You could just type that in the calculator. I'm going to skip it for now. All right, but here's what I want to get to, how we can use these matrices to solve equations. This becomes really, really interesting at this point. So if I didn't lose you already, that's good because this part gets more fun. So here's some equations that I need to solve given the fact that I know that this matrix A is right here. So what this is asking is I have this matrix 2, -1, 4, 3. I need to figure out what matrix do I need to multiply it by that would equal, and for example, 1 here, 1, 3. So this is interesting. You remember how I said earlier how we had, 5x equal to 10? And I said, well, you divide it by 5. Well, we can't divide by matrices. But what we do is the inverse matrix. Remember I said the inverse of 5 was actually 1/5. So if we multiply the 5 by the 1/5, it goes away, but we have to do that on both sides. That's exactly the same thing we're going to do here. Since I already know what matrix A is, if I can find the inverse of matrix A to multiply it with that, then that matrix will cancel itself out, turn it into the identity matrix, basically turning it into 1, which will leave me with whatever this matrix is equal to this. Of course, if I multiply the inverse matrix on the left, I have to multiply it on the right, but I have the calculator that can tell me what this matrix is, so I can multiply them together. So in a sense, let's say, I have A times X. This X is my, mystery matrix that I don't know, equal to 1, not 1/3, but the matrix 1, 3. I'm going to find the inverse of A so that it cancels out over here, but I have to multiply that inverse as well to the right side. Just repeating what I just said a second ago, because why not? And again, not a fraction. Okay. So let's find out what that inverse matrix is. Now we just did that before. We used our calculator to find that inverse. We're going to do it again here. So let's go ahead back to our calculator. If it's still working properly, that is. Try to do this. Nope. Just clear. Just go away. Second matrix. We're going to go to edit. I'm going to edit A because why not? I don't really care. We're going to change it to a 2 by 2 since that's what our problem is referring to. Now our matrix is 2, -1, 4, and 3, I believe. Let me double check. 2, -1, 4, and 3. Yes. So let's go ahead. Let's find the inverse of that matrix. So select that matrix, and now do the inverse of it, and we get some fractions. I guess we can leave them, or some decimals. I think in the book it has them as fractions, but it doesn't really matter either way. You can leave them as decimals. If you do want to change them into fractions, though, remember if you hit, not second, math, enter, it does convert those into fractions. So remember that little trick there. But it doesn't really matter. We'll use the decimals because it's easier to type them in. So 0.3, 0.1, -0.4, and 0.2. So back to our problem here. If I take, so remember this is the original matrix, right? And I'm trying to figure out what this matrix is. That equals, again, not a fraction, 1, 3 matrix. I know the inverse now. The inverse is, from my calculator, I just got it, was 0.3, 0.1, negative point, so -0.4. Yeah, it was -0.4 and 0.2. That's my inverse matrix. So I'm going to multiply that to the left. It'll essentially the inverse. It'll cancel that out completely, but I have to multiply that matrix as well to the right. So I have to multiply this matrix by the 1, 3 matrix by 0.3, 0.1, -0.4, and 0.2. I need to multiply it by that inverse matrix. So if I do this, I'll figure out what this matrix is. So I'm going to take the 1, 3 and I'm going to multiply it to that. So let's go back to our calculator. We'll just have to type in. Now we actually could do that by hand because we know how to do that by hand, but let's get a little more familiar with our calculator. So I need to put in my calculator, I need to put in this 1, 3 matrix. So going back to my matrix, let's go ahead and let's put it in for A. This is a, oops, that's not what I wanted to do. This does get really annoying after a while because you want to hit edit and sometimes you forget to hit edit. This is a 2x1 matrix. It is the matrix 1, 3. So I'm going to put this matrix in as matrix A. I'm going to go back to my matrix screen. I'm going to edit matrix B. I'm going to put the inverse matrix that I just got in here. So that inverse matrix that the calculator just found for me was 0.3, 0.1, negative 0.4, and 0.2. That was that inverse matrix the calculator just done for me. So now I'm going to take these matrices, multiply them together, and call it a day. So let's clear this, or just quit out of that, whatever, it's fine. Actually, I do want to double check one thing since I hit clear by accident. I want to make sure that this is still working properly. I swear, sometimes, man. Okay, yeah, everything's in there as it should be. Just want to double check. All right, so let's go ahead and select the matrices. We're going to do matrix A first because we have to do that one first. We're going to do times our second matrix, which we inputted as our inverse matrix, which is matrix B. So this is that 1, 3 matrix times that inverse matrix, and it equals, gosh darn it, man. What did I do wrong, man? What do you want from me? Oh, we got to do it the other way. We can't. Okay, it has to be B times A, not A times B. Same thing. All right, that's fine. Handle ourselves. Okay, so go back to our matrix. We're gonna have to do B times A. If you paid attention to the dimensions, you would have figured that out, but I did not pay attention to the dimensions because this thing's frustrating me. All right, there we go. This should give us our answer, 0.6, 0.2. Voila. I thought one of them was negative, but that's cool too. Oh, no, that's right. Okay. Whew. Solid work. If I lost you, which I'm pretty sure I did, let me recap what just happened, okay? We had this matrix, 2, negative 1, 4, 3, right? I only did number 1. And I'm multiplying it by some unknown matrix to equal this matrix. All I did was I found the inverse of A. The inverse of this matrix happened to be, what was it again? 0.3, 0.1, negative 0.4, and 0.2. So that was the inverse of A, this matrix, which made that matrix cancel out on that left side. But I had to multiply this matrix to the right side as well. So I multiplied this matrix here, this 1, 3 matrix, by this as well. So times, it's the other way around, but it was times 0.3, it was 0.1, negative 0.4, and 0.2. Technically, this should be in front, and this one should be the second matrix, but it's fine. And that multiplication there gets me this, since all this was already canceled out and completely gone. These two things multiplied together equals that. Again, in layman's terms, it's the exact same thing as that 5x problem that I made before. It's not what I wanted. Remember when I said 5x equal to 10? Well, it's the same thing as the problem that we just did. Is we found the inverse of 5, which is 1/5, right? We found the inverse of that matrix there. That got those to cancel each other out, but I had to multiply that same thing to the other side. So I had to multiply that inverse matrix to this side as well. And that would leave me with x equal to, 10 times 1/5, which is simply 2. But, in our matrix terms, it was this inverse matrix times the 1, 3. But we had to do it the inverse first. So That was our answer. We do that same exact process for number 2 and number 3. Oh, I really don't want to do that right now. Only because my calculator is going to screw up again. It's going to make the video really, really long. All right. Example 5. These are some of the same things. Find A matrix B, which satisfies A, B equals C. This is basically the same thing as the last problem. So matrix A is 2, 1, 5, 3. And remember, it's A times B equal to C. So this is A. I'm trying to figure out what matrix B do I multiply it with that would end up equaling matrix C, which matrix C says is this. So matrix C is 2, 1, 1, negative 1. And we're going to do the exact same thing we did before. I'm going to find the inverse matrix for A inverse matrix, because that's going to cancel out with this. And I'm going to multiply that inverse matrix to the right-hand side to get my answer. So let's type all these matrices in my calculator. All right, let's go to edit. Don't forget to edit. We're going to make this a 2 by 2 matrix. This will be my A matrix. So A is 2, 1, 5, 3. So 2, 1, 5, 3. Let me go back to my edit screen. Let me go ahead and put B in as my answer matrix, my C matrix. C was 2, 1. What? Why? Dude. Edit. Go to edit. There we go. 2 by 2. Fantastic. Okay. 2, 1, 1, negative 1. So 2. Oh, hold on. That's why. Okay. 2, 1, 1, negative 1. All right. So remember, I put my A matrix in as A. So let me go to my, let me clear this. Quit. There we go. Okay, or not. That's fine. All right, so select my matrix. Select matrix A, my original matrix. Find the inverse of that. And that matrix is 3, negative 1, negative 5, and 2. Now, I'm going to take this matrix, and I think if I can do this easier, I have my answer. I'm just going to choose, if I hit second, and then this little negative at the bottom, it's my answer. That should be my matrix. And all I need to do is multiply it with my C matrix, which I typed in as matrix B, I think, actually. So choose that matrix. It was the second one we typed in. We're going to choose that. So this is my inverse matrix, my answer, my inverse matrix times that C matrix, which again, I inputted in as B, so not to confuse you, but to confuse you. Hopefully this works. I don't know. I haven't ever tried it this way, but we're going to find out. Hey, and it worked. So that is your answer. That is your that is the matrix B that refers to in the problem 5, 4, negative 8, negative 7. That's going to be it for this video. Apologize for it being kind of long. If it was kind of long, blame the calculator for that. But yeah, I will. I'll see you guys in the next one. Okay. Section 6.3. Bye.